What is traffic forecasting? Traffic forecasting is the act of predicting future traffic volumes for a given transportation system in a given area. Forecasting future volumes of traffic can be useful for planning roadway infrastructure or for finding the fastest route from point A to point B using an app like Google Maps. This video will primarily focus on traffic forecasting as it's used for planning infrastructure, specifically using the four-step travel demand model. So, before we get into how the four-step travel demand model works, let's talk a little bit about the history of traffic forecasting. The traffic forecasting models used today first came into use in the 1950s and 60s as part of an effort to design new highways to accommodate increasing auto travel, which was spurred by post-war prosperity and more widely affordable housing and automobiles. Prior to then, city and infrastructure planning was focused more on creating a specific physical outcome or environment, and less on how people would respond to that environment. With the rapid rise in auto use, planners were forced to change their techniques to incorporate and rely on human behavior, which created a necessity for models predicting how humans would interact with transportation structures, eventually leading to modern-day traffic forecasting. As mentioned previously, we'll be focusing on the most prevalent model for forecasting traffic, the four-step travel demand model. In this model, humans are treated like negatively charged electrons in a world made up of positively charged locations of interest. People are pulled towards attractors such as places of work or entertainment with a level of traction proportional to that location's attractiveness and how difficult it is to get there. To better understand what's necessary for this model, we'll go through each of its inputs one by one. The first input needed for this system are households. Rather than individuals, households are chosen as the generators of trips in this four-step model. This approach is chosen because a household of multiple adults will likely make fewer trips than if each individual lived separately. Factors like the number of people, cars, and ages are taken into account when determining the number of trips a household will make. The second input required for this model is the locations of places of work. Each trip has an origin and destination, and at least one of them is usually a place of work. The place can be where you work, like an office, or where someone else works, like a shopping mall or restaurant. Since there is almost always someone working at non-residential locations, predicting where people work is the key to forecasting trip destinations. The final necessary input for this model is information about the transportation system in the area that you're modeling. When forecasting traffic in a given area, it's important to incorporate that area's local subtleties. Transportation systems are represented by a network of traffic analysis zones, TAZ, and links, where the TAZs are manageable subdivisions of the larger area being analyzed, and the links represent highways or minor roads connecting them. Important information to know includes the lengths, capacities, and free flow speeds of links, costs of parking within the area, as well as information about public transportation routes and their associated costs. Now that we've gone through the inputs necessary for the four-step travel demand model, we can actually go into the steps of the model itself. The first step of the process is trip generation, in which the total number of trips generated by households and the total number of trips attracted by businesses and other establishments are calculated. The next step of the process is trip distribution. Now that the trip generation step has created beginnings and endings for trips, the trip distribution step will now match them. This step uses a gravity model, assigning an attractiveness to certain destinations that diminishes with distance from the source. This takes into account that while people prefer more attractive destinations, they also like to save time and money. This gravity model accounts for this by diminishing a destination's ability to attract people as distance increases, with distance accounting for the time to get there, as well as any fees or tolls involved. The third step of the process is mode choice, which determines what type of transportation is used for a given trip. A utility function that accounts for the type of trip and the household taking it assigns a utility value to each type of transportation, such as private vehicles, carpooling, or public transportation. Whichever mode of transport has the highest utility is chosen. The final step of the four-step travel demand model assigns a time of day and then a specific route to each trip. Time of day is important to account for roadway congestion at peak hours, as there's a finite number of trips that can be made on a single route. Times are assigned to each type of trip using historical data and expected future growth in traffic levels. Trip routes are assigned iteratively, with trips first being assigned to the fastest routes, and then as congestion begins to occur, new trips are reassigned to alternate routes. The process finishes when no trip can be made faster by a change of route. Travel demand models are evaluated for accuracy using base year conditions and comparing the model's output to actual base year data. The two primary measures for quantifying difference between model volumes and real-world traffic counts are the volume over count ratio and the root measure square error. Here's a look at some tables that show acceptable accuracy using these evaluation methods. In terms of an actual evaluation of travel demand forecasting models, a 2021 study compiled the largest known database of traffic forecasting data and compared measured versus forecast traffic to evaluate accuracy. They found that actual traffic was on average 6% lower than what was forecast. However, this difference was largely due to the Great Recession and its decreased employment rates. It's worth noting that forecasts are on average becoming more accurate as time progresses, as more recent projects have had a narrower spread of outcomes. The last subject to cover regarding four-step travel demand models is uncertainty. Sources of uncertainty in this system largely stem from input values, such as the household, employment, and transportation data mentioned previously. To account for these uncertainties, some revision strategies exist. Such strategies include verifying traffic patterns are being represented correctly, correcting the locations of TAZs, updating TAZs to reflect more recent data, and comparing specific activity centers with real traffic counts and adjusting as necessary. To convey uncertainty in traffic volume estimates, the rounding convention shown on screen is used.